Imagine a cosmic monster so powerful that it can swallow stars, planets, and even light itself. A monster that can warp space and time and rip apart anything that comes near it. A monster that is invisible, silent, and relentless. This monster is real, and it has a name: a black hole. A black hole is a celestial object with an incredibly powerful gravitational force, so intense that nothing, including light, can break free from its grasp. A black hole is formed when a massive star runs out of fuel and collapses under its weight, creating a point of infinite density and zero volume called a singularity. A black hole has three main properties: mass, charge, and spin. The mass of a black hole determines how much gravity it has and how big its event horizon is. The outer edge of a black hole, known as its event horizon, marks the point where the speed required to escape surpasses the speed of light, the ultimate cosmic speed limit. Anything, be it matter or radiation, that crosses this boundary is inevitably pulled into the black hole, unable to escape. The charge of a black hole affects how it interacts with electric and magnetic fields. The spin of a black hole affects how it drags space and time around it, creating a phenomenon called frame dragging. One of the most bizarre and terrifying effects of a black hole is spaghettification. This is the process of being stretched into a long, thin shape, like a piece of spaghetti, by the extreme tidal forces near a black hole. Tidal forces are the difference in gravity between 2 points of an object. For example, the moon's gravity pulls more strongly on the side of the Earth facing it than on the opposite side, creating tides in the ocean. Near a black hole, the tidal forces are so strong that they can overcome the internal forces that hold an object together. As a result, an object falling into a black hole will be stretched vertically and compressed horizontally until it is torn apart into atoms. Why are we telling you all this? Because there is a rogue black hole heading our way, and it could spell doom for our planet. A rogue black hole is a black hole that is not bound to any galaxy, star, or other object, and wanders freely through space. Scientists estimate that there are millions of rogue black holes in our galaxy, the Milky Way, and that they can travel at speeds of up to 10,000 kilometers per second. One of these rogue black holes, named XJ1417+52, was detected by NASA's Chandra X-ray Observatory in 2016. It is estimated to have a mass of about 100,000 times that of the Sun, and to be located about 4.5 billion light-years away from us. However, new observations have revealed that XJ1417+52 is not as far away as we thought. It is much closer and moving much faster than previously estimated. According to the latest calculations, XJ1417+52 is only about 1.2 billion light-years away from us, and traveling at a speed of about 20,000 kilometers per second. This means that it will reach our solar system in about 60 million years, and that it will pass very close to Earth within the orbit of Mercury. The singularity is about the size of a small city, but it has a mass of 100,000 suns. It is moving at a speed of 20,000 kilometers per second, or about 6% of the speed of light. It is so fast that it will cross the distance between the Sun and the Earth in less than 10 minutes. It is so powerful that it will distort the light and gravity around it, creating a phenomenon called gravitational lensing. This unique property allows a black hole to function as a colossal magnifying glass. It bends and intensifies the light coming from objects situated farther away and positioned behind the black hole. As a result, the sky will be filled with strange and beautiful images, like rings, arcs, and crosses that are the distorted light of distant objects. But this beauty comes with a price. As the black hole gets closer to Earth, it will also exert a tremendous gravitational pull on our planet and everything on it. Scientists and governments will try to find a way to stop or divert the black hole, but they will soon realize that it is too late and too powerful. No weapon, no rocket, no bomb, and no laser can affect the black hole. No amount of force, no amount of energy can change its course. No plan, no strategy, no negotiation can save us from its fate. We are helpless, we are hopeless, we are doomed. Some people will try to escape to other planets or space stations, but most will be doomed to stay on Earth. The lucky ones will have access to spaceships or rockets and will try to flee to Mars, the Moon, or the International Space Station. However, they will face many challenges, such as fuel shortages, technical failures, or hostile attacks. And even if they manage to reach their destination, they will not be safe. The black hole will affect the entire solar system and will eventually swallow everything in its path. The unlucky ones will have no choice but to stay on Earth and face the inevitable. What will happen to Earth when the black hole arrives? It is the end of the world, and we are here to witness it. The black hole, XJ1417+52, has reached the orbit of Earth and is now pulling the planet towards it. The singularity is so massive that it covers almost half of the sky, blocking out the sun, the moon, and the stars. It is so dark that it seems like the night has fallen, but it is not a peaceful night. It is a night of horror, of chaos, of death. As Earth gets closer to the black hole, it experiences the most violent and destructive forces ever seen on the planet. The gravity of the singularity is so strong that it distorts the shape and climate of Earth, creating massive earthquakes, volcanic eruptions, tidal waves, and storms. The continents crack and crumble, the oceans boil and surge, and the atmosphere burns and rages. The Earth is being torn apart by the black hole, but the worst is yet to come. As Earth nears the gravitational boundary, known as the point of irreversibility, the black hole's gravitational force intensifies to the extent that it generates a gravitational gradient, resulting in a variation in gravitational pull between two locations on an object. This means that the side of Earth facing the black hole will experience a much stronger gravity than the opposite side, creating a huge difference in force. This difference in force will stretch and compress Earth and everything on it into a long, thin shape like a piece of spaghetti. This is the process of spaghettification, and it is the final fate of our planet and its inhabitants. What will it feel like to be spaghettified? It will be the most painful and terrifying experience imaginable. As you get closer to the black hole, you'll feel a strong pull on your feet and a weak push on your head. You'll feel your body being stretched vertically and compressed horizontally until you are thinner than a hair. You'll feel your bones breaking, your muscles tearing, your organs bursting, your blood boiling, your nerves firing, your brain exploding. You'll feel every atom of your body being ripped apart until you are nothing but a stream of particles. You will feel the agony of death, but you will not die. You'll be alive until you cross the boundary of no return. What will happen when you cross the boundary of no return? No one knows for sure because no one has ever returned from there. Some scientists say that you will enter a region of space and time where the laws of physics break down, and where anything is possible. Some say that you will encounter a singularity, a point of infinite density and zero volume, where you will be crushed to nothingness. Some say that you will pass through a wormhole, a shortcut to another place or time, where you will emerge in a different universe. Some say that you will enter a new dimension, where you will experience a new reality. Some say that you will cease to exist, and that your consciousness will fade away. But these are all just speculations based on theories and equations. The truth is, we don't know what will happen when we cross the boundary of no return. We don't know what lies beyond the black hole. We don't know if there is a way out or a way back. We don't know if there is hope or despair. We don't know if there is life or death. We don't know anything. We have crossed the boundary of no return, and we are now inside the black hole. Here, the laws of physics break down, and time and space become meaningless. We're heading towards the singularity, the center of the singularity, where the density and gravity are infinite. What will we find there? One scenario is that the black hole evaporates due to Hawking radiation, releasing all the information and energy it has swallowed. Theoretical thermal emissions known as Hawking radiation emanate beyond the event horizon of a black hole, a phenomenon paradoxical due to the confinement of ordinary electromagnetic radiation within said boundary, unable to break free. This phenomenon bears the name of physicist Stephen Hawking, who proposed its theoretical framework in 1974. The phenomenon known as Hawking radiation is responsible for diminishing the mass and rotational momentum of black holes, leading to the theoretical concept of black hole evaporation. Consequently, black holes lacking mass from alternative sources are anticipated to dwindle and eventually dissipate. However, this process occurs at an exceedingly gradual pace, particularly for all but the most diminutive black holes. The emitted radiation's temperature is inversely correlated with the mass of the black hole, suggesting that miniature black holes are expected to emit radiation at a higher rate compared to their larger counterparts, thus accelerating their dissipation relative to their mass. If this scenario is true, then the black hole will eventually disappear, leaving behind a burst of radiation that contains all the information and energy that was inside it. This would mean that nothing is truly lost inside a black hole and that the information paradox is resolved. The information paradox is the apparent contradiction between the conservation of information in quantum mechanics and the loss of information in black holes. Another scenario is that the black hole connects to another universe through a wormhole, and Earth emerges in a different reality. A wormhole is a hypothetical shortcut in space-time that could link two distant points or even two different universes. Wormholes are solutions to the equations of general relativity, but they are not proven to exist. They're also unstable and would require exotic forms of matter or energy to keep them open. If this scenario is true, then the black hole could act as a portal to another universe, and Earth could pass through it and end up in a different reality. This would mean that there is more than one universe, and that the multiverse hypothesis is true. The multiverse hypothesis is the idea that there are many possible universes, each with its physical laws and constants. A third scenario is that the black hole creates a new Big Bang, and a new universe is born from the remnants of Earth. The Big Bang is the prevailing cosmological model for the origin of the universe, which states that the universe began as a singularity of infinite density and temperature and then expanded and cooled over time. Some physicists have speculated that the singularity inside a black hole could also trigger a Big Bang and create a new universe within the black hole. If this scenario is true, then the black hole could act as a seed for a new universe, and Earth could be the source of its matter and energy. These are just some of the possible scenarios that could happen at the singularity, the center of the singularity. There may be other scenarios, or none of them may be true. The truth is, we don't know what happens inside a black hole, and we may never know. It remains one of the greatest mysteries of the cosmos, and one of the most fascinating topics of scientific inquiry.